system network, if my distribution system is not reliable, then my smart grid cannot be resilient. Please try to understand the relationship. If the distribution network is not reliable, then the smart grid cannot be resilient. And hence, distribution system reliability become mandatory. Because there will be a question, no? Why we are learning distribution system reliability in the course smart grid? Because the main objective, advanced smart grid means what? Smart grid is the basic system you will learn. But in case of advanced smart grid, we have to make your smart grid more resilient. It is not about getting electricity from renewable. It is much more than that. So if you have like to make your system resilient, or if you want your system to come to normalcy even after a failure, then your distribution network expected to be extremely reliable. And hence distribution system reliability cannot be ignored as a separate entity compared to smart grid. Good. So for that, we need to understand what is reliability matrices. And very importantly, transmission reliability is a very, very common subject. However, distribution system reliability are not very well studied during our undergraduate or postgraduates. So today, perhaps we'll get into reliability matrices. And today's class will be more or less mathematics, mathematics class, very simple mathematics. Hope you will enjoy. And please let me know if you have any doubt in between. Now, reliability matrix are quantitative indicators that measure different aspects of system performance, particularly in terms of continuity of supply and adequacy of services. Now, these matrices enable utilities, planners, and operators to evaluate the frequency, duration, and severity of the severe service interruptions, as well as the system capability to meet the demand under normal as well as contingency conditions. By analyzing reliability indices, stakeholders can identify weak points in the network, plan maintenance schedules, optimize investments, and improve customer satisfaction. Now, these metrics are broadly categorized into load point indices, which assess reliability at specific customer connection points, system reliability indices, which provides an overall performance view of the distribution network, energy-oriented indices, which quantify the amount of energy not delivered due to outages. So normally what happens, whenever there is a issue, there is a disconnection, fault, maintenance, whatever we do, basically you are not catering to your customers in many ways. Sometimes you say the energy I'm supposed to give, I have not given, or the load which is supposed to be supplied has not been supplied, or the overall performance what you expect without any failure. Now you will experience a different performance because of certain failures. So this is what actually we need to analyze. How do you analyze those points? Now, I request everyone to use your pen and paper a little bit so that it will help you, because end of the class, you know what are things need to be calculated. These indices quantify the reliability at individual customer connection points, also known as load point. Let's say MNIT Jaipur is a consumer or a load point of the Jaipur distribution company, let's say. So at my consumer end, I must know how reliable the distribution system is. They're vital for understanding customer side reliability. Okay. Maybe the distribution company may say, I am 100% reliable in supplying the things. But until unless it reaches me, I will not say how good you are. It doesn't affect me. So we need to understand what is the customer level reliability. Even in smart grid, what we are expecting, all my customers must have 100% electricity access, irrespective of the disturbances at any corner of the distribution network. I'm at this point, I'm not bothered what is happening in your smart grid. As a consumer, I must get 100% access, and that 100% access is more stronger by some technology. That is smart grid to me. For a layman, what is meaning of smart grid? My electricity cost must be cheaper, and I must switch on and I must get electricity, and my kids must be able to study during examination hour, and my family members must cook through electric stoves actually as and when they want. Or my grandfather must watch TV as and when he switch on. यही तो है इलेक्ट्रिसिटी एंड स्मार्ट ग्रिड. अब करीब मैंने सिस्टम को स्मार्ट, वी मेड इट वेरी स्मार्ट, बट व्हेन आई स्विच ऑन द टीवी इट इज नॉट वर्किंग. Are you getting my point? That is what is important today. So first we need to understand what is failure rate. Number of failures at load point I per. I will just tell you a little bit more about it. Because in the national context actually we are habituated of power failure. So even adha ghanta 30 minutes failure is acceptable to us. We are very comfortable. It was very good. It came after 30 minutes. Yeah, last time it was 5 hours. But most of the developed nations have not experienced a power failures for last 10 years. उनकी बच्चे have never seen power failure in their life. The moment you say there is a power failure, they cannot imagine. They scratch their head. When I go and talk, in high platforms, put the story actually how the failures occurs and how many people do not get electricity access, they all surprised. Because their kids have never experienced a power cut in their life. Electric vehicle become a casual thing for them because they know I can charge at any point, no issue. But here we are concerned. If I go to a charging station, the charging station may not have access to electricity. That is what actually we have to make our system more. We have improved significantly, but still we have to improve more. So failure rate lambda is nothing but the number of failures per year at each load point I. Okay? What is average outage duration UI? Average duration of outages at load point I in hours per year UI is total outage time at load point I per year. UI is the total outage time at load point I per year. Means at a given year time, how many hours or minutes or seconds I'm not getting electricity access. And what is annual unavailability? Total hours the load point is unavailable in a year. It is essentially the same as UI only. Now indices begins. The first indices we all must have studied, but I'll put you actually in a very different concept. This provides a network-wide measures of performance based on IEEE standard 13662012, very scientific way of defining. The most commonly used indices are SAI-FI, we call it SAIFI, and SAI-DI, we call it SAID. So SAIFI means System Average Interruption Frequency Index. That means the total number of customer interruption upon the total number of customers served. All right, very clear, which is nothing but summation of lambda I Ni upon Nt. Now, what is SAID? SAID is nothing but sum of customer interruption durations upon total number of customers served. That is equal to summation Ui Ni upon Nt. Now, Ni is the number of served customers of LPI, load point. Lambda I is the interruptions. Ui is the duration. The SAID is considered the most common one to evaluate the system performance by calculating the sustained interruptions of each customer in service area during determined period, minute or hours per year. Okay, so this is how we can calculate SAID and SAIFI. Now then we move to system reliability indices. The first one, customer average interruption duration index, that is KD, CIDI. that is sum of customer interruption durations upon total number of customer interruptions, which is equal to summation of UINI upon summation of lambda INI. Average service availability index, that is ASAI, which is customer hours of available service upon customer hours demanded, which is equal to summation of NITH minus summation of UINI upon summation of NITH. What I am interested to say that you can, based on those formulas, you can calculate the indices, what is KD and what is SI. Now, what is TH? TH is considered to be 8760 hours per year, and the improvement of safety index level of the distribution system is the main goal to reduce the number of sustained interruptions that occurs in the power grid. Decreasing the KD index has the tendency to decrease the number of customers' complaints. The KD's outage duration is 1 year. The ASI's available service period is mostly monthly or yearly. So given the data, if the value of UI is known to me, the value of lambda is known to me, then I can easily calculate what is KD as well as SI. Now, one more interesting indices, which is known as CAIFI, Customer Average Interruption Frequency Index, that is total number of customer interruptions upon total number of customers interrupted, that is summation of NI upon CN. These indices give the average frequency of sustained interruptions for those customers experiencing sustained interruptions. The customer is counted only once, regardless of the number of times it got interrupted. All right? Even three, only we calculate one customer who is got interrupted, not the number of times. Now, CN is the total number of customers who have experienced a sustained interruption during the reporting period. Okay? Now, average system interruption duration index, that is ASIDI, which is equal to connected KVA duration interrupted upon total connected KVA served. It provides information on system average duration of interruptions. Moving to energy-oriented indices. These indices are very important to evaluate the load in distribution network. Energy not supplied, that is ENS index, used to calculate the total energy generated but not supplied by the system. So ENS is equal to summation of LAI UI, where LA is the load at location I and UI is the duration of outage. So we can easily calculate what is the energy not supplied. Okay, multiplication of the time as well as the magnitude. Now, what is average energy not supplied? AENS is the total energy not supplied upon the total number of customers served. That is summation of LAUI upon NT. NT is total number of customer served. Now, average customer curtailment, that is ACSCI index. ACCI is equal to total energy not supplied upon total number of customers affected, which is equal to summation of LAUI upon CN. Everything clear? The formulas, the equations, the variables, the definitions. Now, very importantly, loss of load probability index, very, very popular, LOLP. We all must have studied in our undergraduate or postgraduate at least, because this could have been elective actually, power system reliability, or maybe a core subject in case of your masters in power engineering. So LOLP is a stochastic method. It is used for specifying of reserve needs, isn't it? LOLP is currently widely used approach by utilities for the assessment of the generation capacity requirement. Means how much excess energy I must have in my distribution system so that the loss of load probability can be minimized. So LOLP is nothing but summation of PITI, where Pi is the probability of loss of capacity and Ti is the duration of loss of capacity in percent. Means if I have actually 20 generators to cater my consumers, out of 20, actually any generator may fail at any given point of time. So I must have excess capacity so that even if someone fails, I must be able to manage. But what is the minimum excess energy I must have so that I can manage is the question. If someone tells me you are catering actually 1 megawatt, you have 2 megawatt, 100% backup. But that will be more expensive, no? So I must optimize how my loss of load probability can be optimized. Yearly evaluation of LOLP are carried out in 4 steps. Yearly maintenance calculation of generation units and making a schedule, creating capacity outage table for specific weeks, calculating daily outages and submitting days for weekly trend. Calculation can be done again for every week in a year too. Are you clear? So this is how actually LOLP can be calculated. Now, one more interesting index, which is loss of load expectation index, LOLE index continued. LOLE can be calculated from daily peak load change data shown in figure 29.1. A specific outage of capacity assists the system with number of stochastic outage existence and number of time of unit. Because nobody knows how it is going to fail. All of you please have a look. If it is going to be 365 days and the peak load to the minimum load is being captured and duration of loss of capacity, if you assume that and you can see that the capacity in outage can be determined, reserve margin also mentioned, and the installed capacity is mentioned. Means what we are doing, we know the peak, then we keep something above peak, that is reserve, and that will be, the final value will be my installed capacity. Isn't it? Now, out of which there could be a capacity outage, the magnitude and for the duration. For so many hours or so many days, so much of magnitude is disturbed. And the top valley portion is nothing but the magnitude of capacity outage, duration of the period given in x-axis. So what exactly happens that if I, this is the x-axis is nothing but a kind of a time stamp, okay, and this is going to be in megawatt or gigawatt. So this become a gigawatt hour story, In that we are seeing a small chunk which has not been supplied because of loss of access to capacity. So that means the calculation period can get weekly, monthly, or yearly. So we can write down LOLE is nothing but summation of PI, CI minus LI minus 1, where L is the consumption, C is the power capacity, and P is the probability of loss. Now, loss of energy expectation, that is LOE, is given by summation of EI PI, where EI is the energy curtailed in scenario I. Energy index of reliability, that is EIR, which is equal to 1 minus LOLE upon E, where E is the total energy demand over the evaluation period. Is it clear? The Ghost Town Municipal Electric Utility Company, that is GMEU, the Ghost Town Municipal Electric Company, GMEU, has a small distribution system for which the information is given. So what happens? There is an example. There is a small distribution system for which certain data has been captured, practical data. And this company, most likely, I don't know, but probably in any part of the Western world. The load point 1, 2, 3, 4, number of customers 250. I'll go a little slow, but make you understand. 250, 300, 200, and 250. All right. So what I've done actually, the whole load curve actually I've divided into four levels. And first level actually I'm saying there are 250 customers, then 300, then 200, 250, and they are nothing but my NI. Now the average load connected for each customer at load point 1, 2, 3, 4 are given by 2300, 3700, 2500, 1600. So my LT, that is the total load, is going to be 10,100 kilowatt. What is my NT? The number of customers are 1000. Am I right? So 1000 customers consume a total load of actually 10,100 kilowatt or 10 megawatt. Is it okay? Good. Now assume that the duration of interruption is the same as the restoration time. Determine the following reliability indices. So you have been taught today how to calculate SAIFI, CIFI, SAIDI, CIDI, ASAI, ASIDI, ENS, AENS, ACCI. So these are the actually 9 indices for which the formulas have been given to you as of now. Okay. So what we will do, the first one, if you see, the load point affected are going to be 1, 2, 3, 4. The number of customers interrupted, now we are changing it, okay? So the number of customers, affected is going to be 250, 200, 250, 250, that is going to be totally 950. Load interrupted, values are being calculated. And duration of interruption in hour is given. First one is 2 hours, 3 hours, 1 hour, 1 hour. And customers hour curtailed, they are given by 500, 600, 250, 200, that is 1600 hours. Then energy not supplied in kilowatt hour is given by 15 megawatt hour, close to that. Okay, and the number of customers affected is going to be 250 plus 200 plus 250, that is going to be 700. But to me, number of customers interrupted is going to be 950, am I right? So now when I go to the next slide, all of you please have a look. So it is basically, there is a small error here. Am I right? It is 950, not 750, 700. Okay. So now, first actually you calculate what is safety. So what is safety? Summation of Ni upon Nt. Summation of Ni is 950. Nt is going to be 1000. So final answer is going to be 0.95. So you may ask me, the value of, just a minute. Could you see what is NT? NT is 1000, am I right? And could you see what is NI? 950. And then 950 upon 1000 will give me 0.95. So indirectly what we say, 0.95 interruptions per customer served. Okay, similarly, what is CIFI? Summation of Ni upon Cn, that is 950. Okay. So here what they are defining, this is basically a value. This is Cn is given by 700 or Ni is going to be 950. All right. So that case, my CAFE will be 950 upon 700, that is 1.357 interruptions per customer affected. Tell me.
In this safety data, 0.95 means every 100 customers, only 5 are getting full supply.
0.95 interruptions per customer served. Okay, so that means it is not talking about 95 out of 100. It is giving you an indices, information that interruption per customer in a whole system. Isn't it? This example that we have taken, which is very, very worst scenario, in this case, it shows, 95% of people are getting affected. Are you clear? But practically, it could be even 0.0095 also, because that's a numerical exercise. So this is basically helping you to calculate easily, but this is giving a wrong. But it is true that most of the customers actually got interrupted because out of 1,000, 950 got affected. It's a very, very serious case. All right. And 1.357 interruptions per customer affected. Similarly, SAIDI means 1600, that is summation of RI and I upon NT. That is 1.6 hours per customer served. Means out of, a long duration, 24 hours, we are just given 2 hours of electricity, which is worse than India also, this. So probably this could be a system where ghost used to live, or maybe there is no excess of electricity. There are many African places where this is a very common scenario, am I right? And KD that talks about 1.684 hours per customer interrupted. There is one thing, please try to understand. One is affected, one is interrupted, and the other is served. All three are of different meaning. Most of the time we say interrupted and affected are same, but they are not same. Okay? Interruption is okay. System will have some interruptions, but not necessary it will affect me. As a customer, I may be okay. Are you getting my point? Now moving to ASAI, NT times 8760 minus summation RINI upon NT into 8760. That will be close to 0.999. You can also calculate ASI DI, which is 1.515 kilowatt hour per kilowatt. ENS, which is 15,300 kilowatt hour. AENS, which is 15.3 kilowatt hour per customer served. ACCI, which is ENS upon CN, which is 21.857 kilowatt hour per customer affected. Reliability analysis method. Reliability evaluation is classified into two main types. Historical assessment method, that is focuses on past outage data and customer discontinuance record, widely used by utilities to measure and benchmark current performance, used to derive indices like SAIFI, SAIDI, CAIDI, etc. Predictive assessment methods uses historical outage data plus mathematical models to estimate system performance under various scenarios. Two main categories, simulation-based methods and analytical methods, are being adopted. Now, first of all, we get into simulation methods. Simulation method used to analyze large and complex systems that are too difficult for analytical models. First is actually structural function, which uses Boolean logic to model whether a system is operating or failed. Can be applied to series, parallel, or hybrid logical structures. Complexity increases with the number of components and configurations, that is A to B connected with 1, 2, 3, 4, a series logical structure, and a parallel logical structure. 1, 2, 3, 4, and then we can have A to B, which is having actually 1, 2, 3, 4. We can connect them in series. We can also connect them in parallel. Monte Carlo simulation, MCS, simulates component failure based on random sampling, provides probabilistic output such as probability density function, which is very important. Monte Carlo simulation is very important, suitable for nonlinear, complex, or large scale systems. Systems where analytical models are difficult to derive can be numerical or analytical. What are the disadvantages? Requires a large number of samples to reach accurate estimate. Now, if I move to analytical reliability analysis methods, network modeling, which evaluates reliability by solving logical and physical connectivity, popular due to its similarity with distribution breed topologies, effective for evaluating connectivity loss scenarios. Now, if you see the right-hand side, there are two states of Markov model which are very clearly defined. One is down and one is up. The down to up is marked by lambda and up to down is marked with mu. That is average failure rate and average repair rate. So, there is a failure and then you repair also. Now, similarly, you can go to another state where down and derated to up can be connected with many lambdas and mu's for a two-state system. Now, when you go for a Markov modeling, we use actually state transition model to evaluate system states, whether it is working or degraded or failed. There are three states. Now it is working fine, it failed, or in between is degraded, but it's close to fail. Suitable for distributed generation DG with stochastic behavior can model two-state systems up/down, multi-state degraded systems. Now, fault tree analysis FTA, graphical model using logic gates and or to trace how component failure lead to a system level failure top event, which represent complex combination of failures, evaluate basic events like human error, hardware failure, or signal errors. Just a minute. Tell me.
So what is D-rated? From 1 to D-rated?
That is what actually we have a generator. Now it is generating, let's say, 100 megawatt. Instead of 0, now it is giving you 40 megawatt. So the 40 megawatt state is known as my derated state. All right. And 0 means actually failed state. 100 is my working state. Is it okay? Good. So analytical reliability analysis method, which is popularly known as event tree analysis. You may not be applying everything to your applications, but at least you should have an idea. Sometime, if you can at least touch upon little bit of these components in your overall analysis that many engineers may not be aware about even what you're talking. So that will be sometime appreciated. So used to identify accident sequence starting from an initiating event, explore success/failure of safety functions and their effect on the system outcome. Now, components FTA, that is, by analyzing post-fault progression, because when you say the system has to be resilient, means once it fails, you must know how much time it will take to come back. So that is where actually the event tree development model can help how the process normally continues in case of event management system. Now, we need to also calculate, there is one thing which is not being taken care by us. We consider actually the loss of energy is simply acceptable. What we say, if you do not have access to electricity, I simply say you need not pay the bill for those consumption. But that is not the fact. The amount of loss caused because of no energy access, that being never been calculated. Imagine if there is a car manufacturing factory and the supply is not there for half an hour, what will happen to the complete platforms? So don't look at your consumer end. If there is no electricity, I'll go outside and read or I'll play. That is not the case. Industrialization, okay. So if there is no access, imagine there is a internet is not there for 6 hours. Imagine the amount of loss. So that is known as value of loss load calculations. Means how do you calculate the value against a loss of load? All right. What is value of loss load? Value of It can be dollar per kilowatt hour. That means value of avoiding 1 hour of outage or value of consuming 1 kilowatt hour during outage conditions. Although dollar per kilowatt hour resembles electricity pricing units, VOLL is not a price. Retail prices reflect cost of production. VOLL reflect value to the consumer, often higher than the retail price, which is true. Most VOLL studies assume full outages, 0% supply, rather than partial curtailments. So VOLL use VOLL times kilowatt hour unserved, which is equal to estimated cost of outage. This is used in cost benefit analysis, that is CBAs, to justify grid upgrades or reliability programs. Now let's see how do we calculate the cost now. So VOLL, that is value of loss of load probability, is not a single value. It varies with customer type and user, like depending upon the gravity of the application and the context, what time of the day, duration, geographic region, prior warning. All right. So categorizing the component of VOLL, this section breaks down VOLL into cost categories that differs by the sector. Now, for example, for industrial or commercial consumers, direct outage cost include ideal labor or resources because you employed 1,000 people for welding and they have no work to do. It is not like our institution where everything is okay. Private industry you have to deliver, right? And delayed or halted production, as I told you, there is a car manufacturing company, stop manufacturing, great loss. Equipment damage, there are many equipments which damage because of frequent fluctuations. Health and safety risks to employee, am I right? So that is also another challenge, even hospital application. And what are the indirect costs? Supply chain disruption. You parked actually 1,000 trucks to carry those cars today, and the supply is not there. So the 1,000 cars are also, or the 1,000 trucks are also ideal. So the complete supply chain disturbs. Even there is a ship which is ready to take your load in from Mumbai to Germany. Actually, that also get disturbed. And there is another ship which is waiting in the Germany to take to another coast, got disturbed. So the whole ecosystem actually completely get disturbed. Now, for residential customer, it is slightly a small story, but still it is concerned. Direct outage cost include activity disruption, missed work, lost leisure, property loss, health concerns. Indirect cost minimal but may increase with trends like remote work. Now, there is one more important cost known as mitigation cost. So, what we can do for that mitigation? Today, what we are doing, all the shops in Jaipur city will be having a diesel generator in there. So, don't you feel that investment they have made just because there is no reliable electricity supply? So, a businessman also lose around 2 to 3 lakhs of rupees plus oil plus government space. रोड पे तो रख रहे हैं घर में थोड़ी रख रहे हैं. So it's a completely chaos. And then, as a normal customer, what we do? We keep a lead-acid battery in our home. Even today, most part of the country, people have a UPS to get electricity in the evening hour. That also another 30 to 40,000 rupees. Charging the battery after 2 to 3 years, lot of cost. That is also, if you multiply by 1 crore homes, that become billions of rupees. So why we are spending billions of rupees just to get access to electricity? There is too much of cost. So protective gears, grid hardening efforts. So this reduces fuel because they reduce the impact of the outages. They help you backup generators. Okay. So customers with mitigation equipment experience less loss. This cost can also be used to estimate VOLL indirectly. Now, this framework explains VOLL using economy theory, especially demand curves. People don't value electricity directly. we don't see that electricity and money are interlinked. Because most of the time we don't pay electricity bill also in the villages. That's another problem. They value services powered by electricity, AC, lights, and internet. Only when they, don't get access to electricity, then only they feel its value. So these services vary in importance. So value of electricity use is not constant. I will give a very simple example. Uh, in IIT Roorkee, for an example, the load is close to 8 megawatt. You say, and we do have diesel generator of close to 6 megawatt. Almost 100% backup is there with diesel generator. Big tanks with full of diesel and three huge 2 megawatt diesel generator plants are waiting to start. And there are 10 people are employed to maintain and maintenance and operate. And there is no electricity failure, then what is the role of that plant? How many crores of investment? Here also we have diesel generators, across the campus. So must be 100% backup, maybe some extent. So you have again crores of rupees investment. So that we need to understand. So these services vary in importance. So value of electricity use is not constant. Consumers have a downward sloping demand curve for electricity. Willingness to pay WTP decreases with more consumption. High value uses, example, breathing machine, occurs at the top of the curve. Low value uses, example, video games, occur at the bottom. All right? Because many people may not be able to play video games, but that is not really serious concern, but there are many more things. Now we get into the little bit of characterization. Microeconomic frameworks, where figure 30.1 show demand curve of electricity. It is basically the household, am I right? And this is basically kilowatt hour. And if you could see, there are, the right side figure is slightly different. Let me read the citation. Theoretical conceptualization of demand curves corresponding to a specific individual and the different end uses of electricity left, and aggregated demand curve of an entire region that might corresponding to different end consumers of electricity. So this is how it looks like, household and complete regression. So let us analyze what it talks about and what that talks about. And you could see that, this is economics now, an individual demand curve where consumption drops from Q1 hour to Q2 hour as price rises. Means today we do not have time of use tariff, but in 11 kilowatt, 11 kV system, we have a time of use tariff. We call it TOU tariff. Very soon, actually, India will also experience the time of use tariff. If you use during peak hours, you have to pay more. If you use during actually off-peak hour, then you have to pay. So this is another way of handling, the energy requirement. So it says that Q1 hour to Q2 hour. In the x-axis, you see Q1 to Q2. All right, because the price rise from 0.2 to 0.4, the consumption reduced. Yeah, now it is correct. Yeah.
रीशेयर कर दो तो दोबारा से। अब आ गया।
Nice, perfect, okay? Yeah. So I want to retention at this point of time, it is slightly important. So an aggregated demand curve for a region built by combining different consumers' preferences and their average values for electricity services. Now the area under the demand curve above the supply price assumed as the social marginal cost as a horizontal line represent the consumer surplus, that is the value consumers gain from electricity use beyond what they pay. All right. So, these are the devices as you could see. Okay, we have fridge uses, light uses for a particular end user customer, AC systems. And during the outage, the customer lose access to electricity and the VOL is estimated as the lost consumer surplus, that is the area between the demand and supply curve up to the amount of organ electricity. Now, what I wanted to highlight here, all of you please concentrate. In any characteristic, could you see the characteristic? In that characteristic actually, anytime there is a marginal costing for each customer, you could see the electricity price is keep on changing, keep on changing, keep on changing. So each device do have a price, because the electric prices keep on increasing when your load is keep on increasing. So if I do not have particular devices or consumers, then my price will actually come down, isn't it? If I keep on adding, then my price will actually go up. That is for sure. Now, in this right hand side, I think we have created actually n number of actually consumer surplus VOLL in full outages. So that means different prices are actually written at each and every level. Okay, so at a given point, the amount of loss of energy will give me at what energy cost actually we lost my energy. Am I right? And if you see the aggregation retail price of electricity, which is keep on changing, that means consumer surplus lost, that is VOLL, in rolling the blockouts. That means in this characteristic for each and every load at price. Okay, so that means sustainable. supply. Loss from full outage for an individual customer or rotating outage in a region means how much a consumer will lose energy excess and what it is value, isn't it? Value means actually this is basically value of electricity. You should not calculate if I do not get electricity excess, I will be saving 20 rupees. No. At a particular point, isn't it? With 3 rupees of energy, so normally what happens? The general price is let's say 3 rupees, but peak it will be 20 rupees. So normally what will happen? The utility will want not to give access during peak hours. Power cut कब होता है actually? Only during the peak hours. So that means that fellow is actually not giving you access to electricity when the energy is 20 rupees. But you are getting electricity bill reduced by rupees 3. Now you understood what is value of loss of load probability? So that means when I'm paying 3, I'm paying for everything, no? But you only curtail when the diesel generators are on, when it is peak. Then you curtail and you say you don't pay electricity. So it is loss to me or it is the consumer is at severe loss that we don't realize. So I lost 17 rupees per unit of consumption. Okay? No worry. So the difference in areas between the graphs highlights the scale of impact. That is, a total outage of one user causes complete utility loss. A rotating blackout shares across many spreads the outage cost, but still it be all when aggregated. That means if you take this cost to serious calculation, I think it is almost serious, very, very huge cost. Now, implications for economic efficiency and equity. Here we discuss how VOLL based decisions can be economically efficient but socially inequitable. Now, what are the efficiency issues? Rotating blackouts don't distinguish high versus low value uses. Circuits serve mixed customer types, making prioritization hard. Equity concerns willingness to pay, that is WTP, equal to VOLL, but also depends on income. A rich person might have high WTP for air conditioning. A poor person might need electricity for medical devices but have low WTP, isn't it? And then relying solely on WTP, which is an unfair outcome because in hospitals with lower paying patients get cut off, isn't it? So, today, fortunately, we don't have time of use supply. The moment you go for time of use supply, people will love to live in dark for 1 hour a day just to cut their electricity by 70%. Because when you have time of use tariff, whole day will be, let's say, rupees 5. And another time it will be 10. And the third 2 hours will be 35 to 40 rupees. Are you clear? So that is where willingness to pay means a price. One is ready to pay, not to experience any. Who are the customer? For example, airport. Airport pay twice the charge of a industrial customer to make 200% sure. Have you ever seen airports don't have electricity? Ever? Are you clear? So, have you seen any five-star hotel not having electricity? People are fighting in that dining hall because they pay much more. The willingness to pay means they are ready to pay price or 4 times of the payment, but they want 100% assure electricity. Similar to hospitals, Have you seen any hospitals do not have electricity access? No, because they pay. But that is a good idea. You are ready to pay more so that the utility company or distribution company can go for excess electricity. But in that process, actually, many weak customers will not have access to electricity. Okay, because they will say you are not ready to pay, and hence there is no electricity. Today, what is happening in India? We are a kind of a moderate, we say free electricity, 6 hours power cut to everyone, but we'll give free electricity. You see, we are giving free electricity for an example, fine. But what we do now, out of 24 hours, we don't give electricity for 6 hours. That is the peak hours.
Okay.
So the people are okay because if I really make free, no, then it become 5 rupees to me. If I make 18 hours excess and 6 hours no power, that will cost me 50 paisa. Because that time I don't have any customers, I have excess electricity. फ्री देने से भी कोई ज्यादा इशू नहीं होने वाला है. But free electricity, when you say, you must give a reliable free supply, no, that is very expensive. Isn't it? So similarly, we say villages, in the rural India, actually in the past, we used to have a dedicated single phase line in the farming area where a induction meter pump will be used by the farmers. You can switch on, that's basically free electricity, illegal supply. But that power will be available only 2 hours a day, morning 4 to 6 a.m. All the farmers will switch on and go and sleep. Am I right? Government also believes, okay, this is free to the farmers. And that time actually I have enough excess. 4 to 6, the demand is not too high. So let us give an excess. But there are few chaos situations also occurred in the past. Many people, they were so habituated in rural India that this line which is going over the farming land will have access only between 4 to 6. So sometimes they put cloth on that, sometimes they touch it also after 7 a.m. to night because they know there is no electricity, it's a dead wire. And sometimes if you switch on the substation, then everybody is gone. Okay, so what I wanted to say, coming in from a lighter note, the very important part is actually value of loss of load probability is a very, very important concept one must understand. And reliability is one of them. Today, when we talk about smart grid, what we're assuring, where you're putting battery, where you're putting PV, where you're putting control, where you're putting mixed energy management system, reliable power only do. So putting all advanced smart grid mean how reliable power can be given to the consumer. But one thing I like to highlight here, that reliable power access can be given to consumers only when there is a TOU, time of use, and willingness to pay is being officially embedded. Then only you can give access to 100% consumers. To me, time of use tariff is a wonderful one. So you can help your consumers to be very organized, let them use. One thing I can say today, most of the theft power in this country got reduced. Also, the power cut also reduced significantly. So we were not that era of 25 years back. Today we are in a very good condition. But only instead of making constant power, constant pricing throughout the day, and giving free electricity, to me, do not give free electricity, number one. And instead of a constant price, you make a variable price. And let the customer decide whether they want to run their washing machine at morning 4 a.m. or 7 p.m. It is up to their call, but make it more reliable. And the earning will come due to time of use, can get into advanced smart grid implementation. Otherwise, you cannot simply do research which is not practically employable. All right? Very good. So why BOLL exists in electricity but not in other sectors? Why BOLL exists in electricity but not in other sectors? Electricity as a public good, electricity reliability is non-rival. One person's use does not reduce others, non-excludable, hard to provide different level of reliability without costly infrastructure, market failure. No functioning market exists for how much reliability you want. Everyone gets the same reliability. So VOLL is needed as a regulatory pricing tool to estimate outage cost, justify public investment comparison. If there is a milk storage, the market raises prices. But electricity cannot function like this because it has no easy substitute and blackout affect everyone. Okay, so the market for electricity is slightly different. So VOLL, it started in 1970s, reliability award awareness sparked by oil crashes. So economic research into the value of electricity reliability began in 1970s. So today, why that war in the Middle East? Everyone is actually taking the oil and keeping back just to run their diesel generator if needed. It is basically energy, no? Either car, it is basically energy. So for that energy crisis only, people are actually preserving oil actually from one country to other. Ship karte हुए ना, evacuate, they keep on evacuating and keeping store. That is extra capacity under emergency. So basically energy people like to store which cannot be stored in the real time. So economic research into the value of electricity reliability began in 1970s, largely triggered by the oil crisis and a series of major power outages in 1977. New York country blackout, America become blackout, no power. And today they are having 100% access because they have the reserve, energy reserve with them. Early VOL related discussions were more in. So that time they started learning that when New York City become dark, how much billions of rupees they lost because of no electricity access. Even we also experienced because of the blackout. So early VOL related discussions were more engineering focused, emphasizing generator reliability rather than distribution or customer centric analysis. Models used by vertically integrated utilities focused on so load forecasting, generator outage probabilities, construction timelines, targeting a 1 day in 10 years LOLP, loss of load probability, standard for planning. Now, if you go to a brief history of the VOL literature, emergence of cost benefit analysis, CBA in reliability. By the late 1970s and early 1980s, researchers began introducing CBA framework linking system reliability via LOLP to economic cost of outages. These studies showed that the then standard 1 in 10 LOLP might be overly conservative and leading to overestimating capacity. Customer loss functions were introduced to estimate economic damage of outages by relating electricity usage to GDP or industry productivity. So the whole country's economy depends on your reliability. And today, why smart grid is popular? Because people know that without electricity, the country economy cannot grow. In a larger sense, these frameworks help define early conceptual models of ULL even before the term itself was widely used. Now, one simple example, why people are not selling the nuclear technology to any country? Why India is suffering even today to generate electricity? Because people know the moment the technology goes to another country, their GDP will grow. Isn't it? So if there are 5 shops, one shop do not want the customer to go to other space. He will try his level best to get all the customers. Similarly, no country will sell their technology. So people feel that it is with me and I will sow. One is oil, one is nuclear. And both are money basically. There are no more electricity. And that's what the whole war is because of that. Oil and nuclear technology, nothing else. If everyone has oil, everyone has actually nuclear technology, then who will care for others? Everyone become rich. Got it? Very good. So the term VOLL, value of loss load, was formally introduced during the UK electricity market privatization in the early 1990s. It was used to justify capacity payment to incentivize generators' investment in a market-driven model. Replace centralized planning with market mechanism for reliability. And in the UK, VOLL was administratively set at 2.35 pound per kilowatt hour. Okay, that is $3.3 per kilowatt hour in 1993-94, aligning with earlier academic estimates. Now, with the spread of electricity market deregulation globally, VOLL becomes central in capacity market and scarcity pricing regime. So VOLL was embedded as a key parameter in market clearing and investment signals. Studies during this period included Hogan 2003. These are the following references actually one can study, and you can easily understand the VOLL of any country is basically GDP upon electricity consumption in kilowatt hour. What a big statement. And our students even not even aware what is VOLL. They keep on doing research. They must know how my research can impact, advanced smart grid research can impact my GDP of the country. All right. So that means in some policies or simplified studies, the electricity tariff is assumed to represent VOLL typically in a lower bound, and production function model and CGE, that is computable general equilibrium models, simulate the impact of electricity shortage on sectoral productivity effort, that is comfort or inconvenience. Now the advantage, easy to compute using public data, scalable to regional or national planning. Limitations, it misses consumer level heterogeneity, cannot capture subjective reliability evaluation, fails to account for non-market effect, comfort and inconvenience. Measuring the VOL in practice, so survey-based strategies, which uses questionnaires and stated preference methods to direct ask consumers how they use the value uninterrupted electricity. The main techniques, contingent valuation, which asks what would you pay to avoid a 1 hour outage. If you ask 1 hour interruption of electricity, if you like to avoid, how much you are ready to pay? I think today you will pay 500 rupees.
What is the settlements?
But many people will pay 1,000 rupees in this country. And they will say, I'll pay 1,000 rupees, but I cannot bear electricity failure. When you started buying a mobile of 1 lakh rupees, so electricity 30,000 is not a big deal. So contingent ranking, consumers rank different reliability pricing bundles. So the cost questionnaire based on actual past outage event, estimating cost per hour lost during a blackout. Summer season, there is no air conditioners. If I ask a question, how many want to live without AC? People will say 15,000 per month, I'm ready to pay. That is what the situation today. When you drive a car, how many ready to drive without air conditioning? But air conditioning cost is almost 30 to 40% of your total driving cost. So if the per kilometer charge is 20 rupees by an Innova, 8 rupees is just AC cost. If you go to Delhi and come back, so 4,000 is your AC cost. So I think it's a big, big thing, okay? So oil is nothing but electricity. Electricity is nothing but GDP. GDP is nothing but money. So there is a huge circle. So that means country need to be perfect with enough sufficient amount of energy. Okay. So finally, we can say that there is some consumers agree to reduce reliability in exchange of lower tariff or incentives. I may say, if you ask me, I will say, if it is free electricity, I do not mind interruptions. Many people will say, if it is free, you give some time silence, okay for me. But if I'm paying, I'm expecting away. So that means some consumers agree to reduce reliability in exchange for lower tariffs or incentives. Their implied BOL is inferred from BOL is less than or equal to incentive payments upon load curtailed. If a customer accepts $50 to curtail 10 kilowatt hour, then what is the value? BOL will be less than $5 per kilowatt hour. Very, very important. That means if a consumer accepts rupees 50 to curtail 10 kilowatt, means one consumer says, you reduce my consumption from 20 kilowatt hour to 10 kilowatt hour, but you give me 50 rupees. I will do that. So then my value of loss load will be less than or equal to 5 USD per kilowatt hour. So that means he is ready to give indirectly the value is $5 per kilowatt or 5 rupees per kilowatt. Value against bearing the loss. So that is the value of my electricity. Someone is ready to pay 5 rupees for 1 unit loss, 1 unit curtailment. So that means the energy loss value is 5 rupees per unit. All right. We can also see this demand curve estimation. This uses economic theory and observed price response data. Assume the demand function follow a constant elasticity model, as I told you, that is P equal to A times Q to the power 1 upon epsilon, where the VOLL is estimated as equal to integral 0 to Q dq minus P dq, that is at the point O, where P is the price of electricity, Q is the quantity demanded, epsilon is the price elasticity, A is the constant, dq is the demand curve, P is the supply price, and Q is the foregone quantity during outages. All right. So with this also you can calculate what is VOL. So finally, we have a summary. So there are methods which are proxy methods, survey methods, and revealed preference methods. The proxy method, we can, specific approaches are GDP ratio, retail tariff, and in case of survey, it is contingent valuation, ranking, past cost recall method. The revealed preference could be interruptible contracts, demand curves, backup investment, and so on and so forth. So, a bar graph comparing VOLL estimates from survey-based method. Let us assume n equal to 84, proxy model n equal to 48, and then revealed preference method n equal to 2. Okay, and shows VOL estimate ranging from $1 to over 50 per kilowatt hour. So different methods estimate different value of loss of loads. It varies from $1 to $50. Okay, so this is what actually the study says. So there is no, for you, the value of loss of load is different than for Manmohan, somebody else. For example, for Reliance, he will pay infinity costs not to have any power cut. If you ask him, he'll say, I pay 1,000 rupees per unit. So it varies, no? So the overall study says that it varies from 1 rupee to 50 rupees for all the consumers. Even many times, I don't know, I mean, here also in India, we started doing it. Even in UK, or even in US, when you travel by a train, depending upon the time of the train, the price is different.
Flight in India.
So something like flight. Exactly.
Dynamic.
Now, even in train also we introduce a variable price now.
Duranto.
Yes. All right. So similarly, electricity also should be a commodity, and the price of energy excess must vary from time to time. When you can pay variable price to flight, why not variable price to electricity?
Dynamic price.
Huh?
Dynamic pricing.
It should be. That is time of use tariff. Okay. So this is how actually it has been calculated from different countries. It's basically a case study. This is for the different consumers. So with this, we come to an end today. So it's something like, today's talk is relatively conceptual, uh, but it has huge impact on smart grid implementation. Normally, we don't teach in basics of smart grid. We say it is fine. But millions and millions of dollars or pounds or rupees must be invested by a utility company to have 100% energy access. So for that, a variable price, reliability cost is also equally important. No, energy is there, but you are not getting access to energy because the conductor is not there, transformer is not there, interruption is there. Interruption means device interruption. So there is an economy in the energy and there is an economy in the infrastructure, physical infrastructure. And both are actually playing a key role to connect between a smart grid to a consumer. All right. So this is a very, very important customer for realizing those things in practice. Why we are paying more price in a flight when you want your sleep should not be disturbed? I'll take a flight at 10 o'clock. But I take a flight at 4 o'clock. I don't sleep all night because it is cheaper. Get it? The same thing must be done. So I may get up at 11 p.m. and run my, even you don't mind cooking at 3 p.m. If the electricity is cheaper for the evening meal, you can just cook and keep it. Do you mind if I say free electricity? I don't mind actually. I can run my micro oven at 4 a.m. Isn't it? So I think this is very important. The reason being you are having access to intermittent energy supply, the solar, the wind. That is my main modern system, no? And those energies are intermittent. And if I give you energy access all the time, then I have to put battery. And that will be 3 to 4 times of the extra cost. So this is very commonly, but normal people do not understand, but we power engineers must understand it. तो पीवी जैसलमेर में पीवी सिस्टम लगाने के बाद भी वो कहेगा रात को मेरे को बिजली चाहिए, फ्री में चाहिए. कहाँ से? How do you get it? Isn't it? So that's a very, very interesting concept. So with this, I request everyone to, a lot of hard work has gone in preparing those slides. So please read thoroughly and hopefully we can continue again tomorrow. Thank you very much. Bye-bye.
Thank you, sir. We'll conclude our session today. Thank you.
आज कितने बच्चे थे? 20, 25?
50 plus.
50 थे. Very good. All of them.